Hey, do you want to know how to use your phone or multiple phones to control a Ventuz scene, like here in the example behind me? In this example, I use my iPhone to control that model in the Ventuz scene in real time, basically. Come on, let's jump right in. So we are here in a new empty scene. What you also need is a phone and an OSC application. There are multiple OSC applications out there, like Touch OSC or GyrOSC. In my case, I'm using here GyrOSC. I will also put that correct link down in the description. And you also have to make sure that your phone and your computer are in the same Wi-Fi network, because they need to communicate via OSC, right? So the phone needs to communicate with the Ventuz OSC nodes. Okay, let's jump right in. So first thing what we need, we will create an OSC input. And with that OSC input, you can see we have a port, we have multicast IP address, and so on. In our case, I have to type in here only the address. And of course, you also have to make sure that firewalls not blocking any OSC communication and things like that. So here on the screenshot of that GyrOSC application on my phone, you can basically see we have a target IP address, we have a port, we have a tag, and then we have down there all the OSC addresses, right? In the target IP address field in your phone, you have to make sure that you type in the IP address of the computer that is running Ventuz. And also make sure that the port is the same like here in the Ventuz OSC input node, okay? So the next thing we have to do, we have to type in the correct OSC address of the values we want to get from our phone. Of course, you can also add multiple OSC inputs to fetch multiple data from this OSC application on your phone. So let's do that. I type in here that address to get my gyrometer data. So that's GyrOSC /gyro. And that's basically everything already. And if your phone is in the correct network, then you can see already messages will arrive here, right? The next thing we have to do, we have to add outputs. As you can see on your gyroscope address in the brackets, they tell you pitch, roll, and yaw. And that's exactly the three values what we want to fetch in Ventuz. Mostly that values are float values. So let's add three float values here as output. So float one for the pitch, then another one for the roll, and another one for the yaw. So let's also rename them quickly. Let's call that X, Y, Z. And as you can see, if I use my phone now and I roll it over the x-axis, right, then you can see the x value here is 1.5. If I roll it back, then you can see our x-axis minus 1.5, right? And the same with the y-axis right here, plus 1.5 and minus 1.5. And the same with the yaw, right? If I rotate it like this, but there you can see we're going here up to 3 and minus 3, right? Okay, since we have now real-time access to our phone's gyroscope data, basically, the only last thing what we have to do is building a very simple application like a cube with some clipping nodes to map the values we get from the phone to our Ventuz scene. Let's do that. Okay, so last thing we have to do, we simply have to attach our values from our OSC, which are coming from the phone, to our axis of that phone and of the display and everything, right? So let's bring that back. So this one here is basically our X, right? So let's do that. Let's connect now the X rotation to our X from our phone, right? And as you can see a little bit already, something is happening, but that's not enough. Let's clip these values. Let's put the clipping node here. And we know already, we talked before, minus 1.5 to 1.5, right? So these are the input values from our phone. And we want to have it map to 90 and minus 90, right? And as you can see, if I move my phone now over the x-axis, it's actually happening directly in real time in my Ventuz scene. So let's do that with the last two values. And here we use also, let's see, we use here the Y. The Y is actually the set, that's a yaw, right? So let's connect this to our set. Let's also bring there a clipping node. And here we have, so you remember, here we talked about -3 and 3, and we checked the values before. And we know it's 180 to -100. Let's check that out. And as you can see, that's also working like expected. And the last binding we need, let's do that clipping later. The last binding we need is for our set, and that set is coming from our Y. Let's also bring a clipping node here. And here we had the same like with our pitch basically, right? So here we also had the -1.5 to 1.5, and we have 90 to -90. And that should do the job. So now we have full control about that Ventuz model of a phone with our phone in real time. I hope you like it. If so, please press like and subscribe. Until next one, bye bye.